In the third episode of our Python OOP series, we are going to explore what are class attributes, and we are also going to learn what are magic attributes and what are the most useful magic methods that we can come up with them. Now, about class attributes, there is always one class attribute that I always go ahead and create in order to speed up my development and save expensive time. And that is something that we're also going to take a look in this episode. So there is a lot to expect from this episode, and with that being said, let's get started. Alright, so until this point, we learned about how to work with the constructor, and we also learned about how to assign different attributes to instances that are going to be unique per instance, which means that you can go ahead and create as much as instances as you want, and you have the control to pass whatever values you'd like to for the name, price, and quantity. Now consider a situation that you want to make use of an attribute that is going to be global or across all the instances. Now a good candidate for an example of this could be a situation that you want to apply a sale on your shop. So this means that you want to go ahead and having the control of applying some discount for each one of the items. And that is a good candidate for creating an attribute that is going to be shared across all the instances. Now we call those kind of attributes class attributes, and the kind of attribute that we have learned till this point is actually called in a full name instance attributes. So about instance attributes we know everything and we learned how to work with it, but we did not work it with the other kind of the attributes, which we will do in this tutorial, which is called again a class attribute. So a class attribute is an attribute that is going to be belong to the class itself, but however you can also access this attribute from the instance level as well. Let's go ahead and see a good candidate for a class attribute that you want to go ahead and create it. So that's gonna be going to our class here, and just in the first line inside our class I can go ahead and create a class attribute. So let's go ahead and create an attribute like pay rate equals to 0.8. And the reason that I'm doing this is because I said that there's going to be 20% of discount. So I probably want to store an attribute that will describe how much I still need to pay. So I will say here the pay rate after 20% discount, like that. Okay, so now that we have created this, then let's see what are the ways that we can access this attribute. Now, if I was to go down and actually deleting one of those, and say something inside this print line that will look like the following. So I will try to access to the reference of the class itself. So I'm not going to create an instance like that. Besides, I'm just going to bring in the reference to the class level itself. And I'm going to try to access this attribute by saying pay underscore rate. Now, if I was to run that, then you're gonna see that as expected, we see this class attribute because that is a way that you can access those class attributes. Now, this might be confusing, but I said a minute ago that you can also access those class attributes from the instance level. Well, let's see if that is true. So if I was to duplicate those lines twice by using the shortcut of Ctrl D, then let's go ahead and change those to item 1 and this one to item 2. Now see how I try to access the pay rate attribute from the instance, although we don't have such an instance attribute. Now if I was to run that, then you're gonna see that we still have the access to see that class attribute. Well, that might be confusing and that might be hard to understand why that is happening. Well, there is actually something that we need to understand when we work with instances in Python. So when we have an instance on our hand, then at first this instance tries to bring the attribute from the instance level at first stage. But if it doesn't find it there, then it is going to try to bring that attribute from the class level. So what that means? It means that item 1 did some thinking here and say to itself, okay, so I don't have this attribute right in here because that is just not an attribute that assigned to me. So I'm going to try to search that from the instance level and then I'm going to find it and print it back. So that is exactly what is happening here. Item 1 and item 2 are instances that could not find the pay rate attribute on the instance level. So both of them went ahead and tried to bring this attribute from the class level, and since it really exists in the class level, then we were able to access those. Now to even give you a better idea of what is going on here, then I'm going to do one more additional thing. Now I will delete this first print line, and I will go ahead and delete those attributes from here as well. Now there is a built-in magic attribute, not a magic method, that you can go ahead and see all the attributes that are belonging to that specific object. And that is achievable by using this double underscore dict double underscore like that. So this will go ahead and try to bring you all the attributes that are belonging to the object that you apply this attribute and want to see its content. So I will go ahead and copy this one and paste this in for the instance level as well. So this should give me all the attributes for class level, and the second line should do this for the instance level. Alright, and if I was to run that, then let's explore the results for a second. Now you can see that at the first line we see this pay rate attribute, but in the second line we never see it. We see name, price, and quantity. And you can also pay attention that this magic attribute is actually responsible to take all the attributes and convert this to a dictionary. And that is from where the dict keyword coming from. It is just a shortened version of a dictionary. So that is a very useful magic attribute that you can go ahead and use if you just want to see temporarily, for debugging reasons, all the attributes that are belonging to some object. Alright, so now that we understood this, then let's take it to a real life example and come up with a method that will go ahead and apply a discount on our item's price. So that will be by creating a method that will belong to each of our instances. And that means that we can go ahead and come up with a method that we could name apply discount. So let's go ahead and start working on this. So I'm going to say def apply discount, and pay attention that I'm using a new method inside a class here. So right inside of this, then at first we need to figure out how we are going to override an attribute that is belonging to an instance. And we already know that we can do that with the self keyword. So it will be self dot price, and that will be equal to self.price, meaning the older value of this attribute multiplied by the pay rate. Now you might expect that we could access this directly like that, but if you remember, that is actually belonging to the item class itself. Now this might be confusing because this method already inside this class, so you might think already that you can access it directly by saying pay rate because it is already inside the class. But that is actually not going to work, because you can either access it from the class level or the instance level as we understood previously. So I can go ahead and say item.payrate like that, and there you have a method that can go ahead and basically override the price attribute for one of your items. Now to show you that this works, then I can only use one instance for now, and I can go ahead and call this method by say apply discount, and I can also now try to print the attribute of price for this item 1, and we should see 80, right? So if we were to run that, then you're gonna see that we are going to receive 80.0 as expected. Now we should not forget the option that you might also want to have a different discount amount for a specific item. So say that one day you'll have 20 items, and only for the laptop you want to have a 30% discount. But it is going to be a bad idea changing the class attribute to 0.7, because it will affect all the items that you have right now on your hand. So what you can do instead is you can assign this attribute directly to one of the instances that you would like to have a different discount amount for. So let's go ahead and see an example for this. So I will allow myself to bring back the item of laptop, and then what I can do to apply a 30% discount for this item is assigning the exact same attribute to the instance. So I can go ahead and use a item2.pay_rate is equal to 0.7. Now what will happen here is that for item 2, it will find the attribute of pay rate in the instance level. So item 2 does not really have to go ahead to the class level and bring back the value of pay rate, because at first look it is going to find it in the instance level. But for item 1 it is different. It is still going to read from the item level, which is going to be 0.8. So now if we were to try to use item2.apply discount and as well as printing the price now, then let's see what will happen. So I will uncomment this line to not see this print for now, and I will go ahead and execute our program. Now you can see that we still, however, receive 800. And what this means? This means that the discount that has been applied is still 20%. And where this is coming from? Well, this is coming from this method here, that no matter what, we try to pull the pay rate from the class level. So a best practice here will be to change this to self. And that way, if we override the pay rate for the instance level, then it is going to read from the instance level. But for item 1, if we try to access the pay rate from the instance level, then this is still great because we did not assign a specific pay rate for item 1, so it is going to pull that from the class level. Now, if we were to try to run that, then you're gonna see now that we have expected results. And if we were to also uncomment the first print line for the item 1 and rerun our program, then you can see that for item 1 we had 20% discount, and for item 2 we had 30% discount. So when it comes to accessing class attributes, you might want to reconsider how you want to access them when you come up with some methods. And specifically for creating a method like apply discount, it is a great idea to access it from the instance level, so you also allow the option of using a pay rate that is assigned to the instance level. Okay, so now that we understood completely about the differences between a class to an instance attribute, let's jump ahead to the next topic. Now you see that I have deleted those print lines that I have down below, and I came up with 5 instances that I have created here. So you might also want to create those 5 instances immediately, so that is why I will recommend you to go ahead to my repository, accessing this class attributes directory, and then code snippets, and then go ahead and copy the code from this 5_items.py file. Okay, so considering a situation that your shop is going to be larger in the future, meaning that you are going to have more items, then the more items that you are going to have, the more filtration-alike things that you want to do in the future. But what is problematic currently with our class is the fact that we don't have any resource where we can just access all the items that we have in our shop right now. Now, it could have been nicer if we could somehow have a list with all the item instances that have been created until this point, but currently there is not an approach that will give us a list with 5 elements where each element will represent an instance of a class. So in order to come up with such a design, then here is a wonderful candidate for creating a class attribute that we could name all. And once we do this, then we're gonna see how we are going to add our instances to that list. So I will go ahead and start by going here and use an all attribute. So it will be all equals to an empty list. Now we need to figure out how we are going to add our instances for each time that we are going to go ahead and create an instance. Now if you remember, the _init method is being called immediately once the instance has been created. So it might be a wonderful idea going down below inside this _init method and use a code that will be responsible to append to that list every time that we create an instance. And that will be as easy as saying something like the following. So first, you could pay attention that I actually wrote some commands in this _init function, like run validations and assign to self object. So it might be a great idea to start with a comment here that will say actions to execute, just to really have a great separation between the different things that we are doing. So now inside here, I can say item.all, and you can see that I use the class object first. And then that is a list, so I can use .append, and then I will just append the self object. Now we know that self is actually the instance itself every time that it is being created. So once we go ahead and launch such a command inside the init function, then for each instance that is going to be created, this all list is going to be filled with our instances. Now to show you that, I can jump a line after we create the instances, and we can say print item.all. And now if I was to run our program, then you are going to see that we're going to have a list with 5 instances. If I was to scroll right a bit, then you can see that I have exactly 5 elements, and that is perfect. Now that's going to be extremely useful if you want to do something with only one of the attributes of your instances. So say that you would like to print all the names for all of your instances, then you can use easily a for loop to achieve such a task. So you can go ahead and say for instance in item.all, and you can say print instance.name. And once we come up with this, then you can see that we have all the names for all the instances that we have created. So that is going to be useful here and there, especially if you know how to use the filter function, for example, to apply some special things on some of the instances that are matching your criteria. Alright, so now that we understood this, then let's also take care of one problem that we saw previously. Now, if I was to use a Ctrl-Z a couple of times and still use this print item.all, now you could see that the way that the object is being represented is not too friendly. Now, it could have been nicer if we could somehow change the way that the object is being represented in this list here. Now, there's actually a way to achieve this by using a magic method inside our class. Now, there is a magic method that is called _repr, and repr stands for representing your objects. So that is why you can actually go ahead and use this magic method, and then you will have the control to display your objects when you are printing them in the console. Now, I actually recommend watching a video that compares between a method that is similar to it, which is called _str. And you can take a look in the description of this entire series to actually watch the video that I'm talking about. Alright, so let's go ahead and use the repr method to understand how this is going to work. So I'm going to say def inside our class, and I'm going to use _repr and as expected it will receive the self. Now what we can do now is returning a string that will be responsible to represent this object. Now obviously we don't want to use something that is not unique for each of the instances, because say that I was to use now return item, something like that, and run our program, then you can see that I'm going to receive a list with this string 5 times, but it is going to be hard to identify which instance represents each string here. So it could be helpful if we were to return a string that could be unique. So I'm going to close the console here and go ahead here and use a formatted string, and in order to make this unique, it is a best practice to represent it exactly like we create the instance like that. So what I'm going to do here is leaving the item and use a brackets opener and a closure, and then I'm going to make the return string here as much as equal as possible to the way that we create those instances. So I will start by typing here single quotes to escape from the double quotes that are coming from here, and I'm going to refer to the value of name by using self.name, and then I will leave my single quotes and I will use a comma like that, and then I will go ahead and refer to the value of our price. I will use one more comma and I will say self.quantity. Now if we were to execute our program again, then you can see that now we receive a list that is way more friendly than what we have seen previously. And you can also see that this first element, for example, is quite equivalent to this line here. Now you might be curious why I worked so hard to return the representative version of our objects the same way that we create them. So that is just a best practice according to Python's documentations, because it will help us to create instances immediately by only the effort of copying and pasting this to a Python console. So if you think about it right now, if you open a Python console and you import this class, then it will be as easy as grabbing this and pasting to the Python console, and then you will have an instance being created. So that is the single reason that I have came up with this approach, and also for sure I just wanted to return a unique string that will really represent our instance. And you can see that it is very easy to identify the instances of our class with this list and with this approach. Alright, so that's it about the third episode, and I hope you gained some new information that is going to be useful for your Python projects. Now, as usual, if you enjoyed this video, please hit the like button and as well as consider subscribing to my channel so you will never miss a video. I will see you in the fourth episode.